Every morning at 9 a.m., your order's API's p99 latency jumps from 200 ms to over 1.2 seconds. The culprit? Lambda's default on-demand concurrency reclaims all containers after just 15 minutes of idle time, and the morning traffic burst triggers a wave of cold starts. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover Amazon Web Services Lambda Serverless. Amazon Web Services Lambda is a function-as-a-service platform. You upload code, configure a trigger, and Amazon Web Services handles scaling and infrastructure. You pay only for compute time consumed. When a trigger fires, Lambda either reuses a warm container or boots a new one. That boot is the cold start, and it's where latency hides. Code outside your handler runs once during cold start. Put expensive initialization there to reuse across invocations. Here's a real Lambda function that resizes images uploaded to Simple Storage Service. Notice the Simple Storage Service client is initialized outside the handler, so it's reused on warm starts. Lambda needs a trigger to run. The most common are API Gateway for REST APIs, Simple Storage Service for file events, Simple Queue Service for decoupled processing, and Event Bridge for cron jobs. This handler processes post orders via API Gateway. It validates input, creates a DynamoDB record, and returns the order ID. Note the core's headers. Different triggers have different invocation models. Asynchronous triggers retry twice, synchronous do not retry, and stream-based triggers retry until data expires. Always configure a dead letter queue for async triggers. Memory is the only performance dial. CPU scales proportionally, so doubling memory can have execution time, often keeping cost the same. Use the Lambda Power Tuning tool to find the sweet spot. This SAM template defines a Lambda function with 512 MB memory, provisioned concurrency of 5, and an API gateway trigger. It also creates a DynamoDB table with paper request billing. Provisioned concurrency keeps a set number of containers always warm. It eliminates cold starts for those slots, but you pay for idle time. Use it only for latency-sensitive paths. This snippet from the SAM template enables provisioned concurrency. After deployment, verify with the Amazon Web Services CLI command shown. Lambda has hard limits. Know them: memory up to 10 GB, timeout up to 15 minutes, deployment package 50 MB zipped, and default concurrency 1000. Exceeding these causes failures. Lambda's retry behavior depends on invocation type. Synchronous calls don't retry, asynchronous retry twice, then go to DLQ, stream triggers retry forever. Always attach a dead letter queue. Use structured JSON logging with the X-ray trace ID for correlation. This example logs different severity levels and includes error details. Lambda isn't for everything. For long-running jobs, stateful applications, steady traffic, or GPU workloads, consider alternatives like Elastic Container Service, Elastic Compute Cloud, or SageMaker. This quick reference helps choose the right compute service. Lambda for event-driven, short tasks, Elastic Container Service for containers, Elastic Compute Cloud for full control. Serverless means Amazon Web Services manages the infrastructure. Event-driven means your function only runs when triggered. Design handlers to be stateless and idempotent. This CloudFormation template creates in Simple Storage Service Bucket a Lambda function triggered on object creation and a DynamoDB table for metadata. No servers to manage. Lambda excels at short, asynchronous tasks like image processing, webhooks, scheduled jobs, and file transformations. These are bursty and scale to 0. This template creates a scheduled Lambda that runs every 15 minutes to clean up expired sessions. The DynamoDB table has TTL enabled for automatic deletion. Lambda pricing is simple, pay per request and compute time, but costs add up with sustained traffic. Always benchmark and set budget alerts. This YAML estimates monthly cost for 10 million requests at 128 MB and 500 ms duration, about $5.75. After free tier, it's still low, but larger functions cost more. Lambda's key features are automatic scaling, native integration with 200+ Amazon Web Services, isolated execution environments, and pay-per-use pricing. This is the same issue we highlighted at the start. Here's exactly why that happened. At 9 a.m., a wave of concurrent requests arrived. No warm containers were available, so each request triggered a cold start. The Java JVM initialization added 800-1200 ms before the handler even ran, causing the p99 to spike. The fix was to enable provisioned concurrency with 5 pre-warmed containers. Now, when the 9 a.m. spike hits, requests are routed to warm containers, eliminating cold starts. The p99 drops back to normal. Provisioned concurrency costs money even when no requests come in. For a function invoked once per hour, a scheduled warmer is cheaper. Monitor spillover to adjust the count. This is the exact mistake that caused the 9 a.m. spike. Without provisioned concurrency, every concurrent request during traffic bursts triggers a cold start, adding seconds of latency. Without a DLQ, failed asynchronous invocations disappear after 2 retries. You'll never know they failed. Always attach an simple queue service queue or simple notification service topic as a DLQ. If your Lambda-backed API works in Postman, but fails in the browser with a CORS error, you're missing the access control allow origin header. You also need to configure the options preflight method in API gateway. The 50 MB zip limit applies only to direct upload. Use simple storage service deployment via SAM or CLI to bypass it. The 250 MB unzipped limit still applies. For steady traffic, Lambda can be more expensive than a small elastic compute cloud instance. Always run a cost simulation before migrating. Amazon Web Services Lambda SnapStart, launched in 2023, reduces Java cold starts by caching the initialized runtime snapshot. It can cut init duration from 1.2s to under 200 ms with no code changes. Enable it via the console or SAM with SnapStart, true on your function. Note: SnapStart is incompatible with certain features like preloading of random seeds or unique IDs. Test thoroughly. The article mentions the Lambda Power Tuning tool, but doesn't show how to invoke it. This snippet runs the tool via Amazon Web Services CLI, testing memory from 128 MB to 1024 MB in 64 MB steps, and outputs the optimal memory setting for cost or performance. The article warns about spillover, but doesn't explain how to monitor it. Use the CloudWatch metric, provisioned concurrency spillover count, to track how many requests exceed the provisioned pool. Set an alarm on this metric to adjust your provisioned concurrency level proactively. To debug cold starts, check the init duration in CloudWatch logs. Monitor provisioned concurrency spillover to see if you need more pre-warmed containers. Use X-ray to trace latency and run Lambda Power Tuning to find optimal memory. Let's run through some common interview questions. What is a cold start and how do you mitigate it? Cold start is latency from initializing a new container. Mitigate with provisioned concurrency, smaller packages, or faster runtimes. How does Lambda pricing work? Pay per request, 20 cents million, and compute duration, GB seconds. Free tier, 1M requests and 400 KB seconds. When would you choose Elastic Container Service over Lambda? For long-running processes, 15 min, stateful applications, or steady traffic where Lambda is more expensive. And a few frequently asked questions. Can Lambda run longer than 15 minutes? No, hard limit. Use step functions or Elastic Container Service for longer jobs. Is Lambda cheaper than Elastic Compute Cloud? For spiky traffic, yes. For steady traffic, Elastic Compute Cloud can be cheaper. How do I reduce cold starts? Use provisioned concurrency, choose Python node, minimize package size, or use SnapStart for Java. To recap, cold starts are the main performance gotcha. Use provisioned concurrency for latency-sensitive endpoints, tune memory with power tuning, always set a DLQ, and know when Lambda isn't the right tool. Ready to go deeper? Up next, Amazon Web Services Fargate. Serverless containers on Elastic Container Service and Elastic Kubernetes Service, then Amazon Web Services Elastic Kubernetes Service, then Amazon Web Services' Simple Queue Service and Simple Notification Service. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.